Why do galaxies rotate in a way that seems to defy gravity? When astronomers first measured how stars move inside galaxies, they expected the outer stars to orbit more slowly than the inner ones. Instead, they discovered something puzzling. Stars at the edges of galaxies were moving just as fast as those near the center. What unseen force could be holding galaxies together? This is Mattermosaic, piecing together the universe, one discovery at a time. To understand the mystery, we begin with how gravity normally works. In a system like our solar system, most of the mass is concentrated in one place, the Sun. Because of this, planets closer to the Sun orbit faster, while those farther away move more slowly. Astronomers expected galaxies to behave in a similar way. In a typical galaxy such as the Milky Way, most of the visible matter is concentrated toward the central bulge where stars are densely packed. According to classical gravitational physics, stars farther from this center should orbit more slowly because less mass lies inside their orbit. However, observations revealed something very different. When astronomers measured the rotational speeds of stars across galaxies, they found that stars in the outer regions were moving far faster than expected. Instead of slowing down with distance, the rotation speed remained nearly constant across the galaxy. These measurements are known as galactic rotation curves. A rotation curve plots the orbital speed of stars against their distance from the galactic center. If only visible matter existed, the curve should drop off at large distances. Instead, astronomers observed a flat curve, meaning stars continued to move at high speeds, even far from the center. This surprising result suggested that galaxies contain far more mass than what telescopes can see. One of the scientists who played a crucial role in confirming this mystery was astronomer Vera Rubin. In the 1970s, Rubin and her collaborator Kent Ford carefully measured the rotation curves of many spiral galaxies. Their results showed the same pattern again and again. No matter which galaxy they studied, stars at the edges were moving too fast to be held in orbit by the gravity of visible matter alone. If galaxies contained only stars, gas, and dust, these outer stars should have escaped into space. The logical conclusion was that galaxies must contain a large amount of invisible mass. Scientists call this mysterious substance dark matter. Dark matter does not emit, absorb, or reflect light, which makes it impossible to detect directly with telescopes. Yet its gravitational influence is clearly visible in the motion of stars and galaxies. Astronomers now believe that every galaxy is surrounded by a massive halo of dark matter. This halo extends far beyond the visible disk of stars. The additional gravitational pull from this unseen mass helps keep fast-moving stars bound to their galaxies. In fact, dark matter appears to make up the majority of matter in the universe. Current cosmological measurements suggest that only about 5% of the universe consists of ordinary matter, the atoms that form stars, planets, and living things. Roughly 27% is dark matter, while the rest is another mysterious component known as dark energy. Dark matter not only influences the rotation of galaxies, but also shapes the large-scale structure of the universe. Galaxies and galaxy clusters appear to form along vast filaments of matter stretching across space, often referred to as the cosmic web. Without dark matter, these structures might never have formed. Computer simulations show that the gravitational pull of dark matter helped gather ordinary matter into the first galaxies during the early history of the universe. Scientists are still trying to understand what dark matter actually is. Many theories suggest it could consist of unknown particles that interact very weakly with ordinary matter. Experiments around the world are searching for these particles using sensitive detectors, placed deep underground or inside particle accelerators. Despite decades of research, dark matter has never been directly observed. Yet the evidence for its existence continues to grow through astronomical observations. Galactic rotation remains one of the strongest clues. The way galaxies spin reveals that most of their mass is hidden from view. This discovery changed how scientists understand the universe. Instead of being built only from visible stars and gas, the cosmos appears to be structured around an invisible framework of dark matter. Every galaxy we observe, including the Milky Way, may be embedded inside an enormous halo of unseen mass, guiding its motion through space. The stars we see are only the visible surface of a much larger cosmic structure. This is Mattermosaic, piecing together the universe, one discovery at a time. If this exploration changed how you think about the hidden forces shaping galaxies, share it with someone curious about the mysteries of the universe, and let us know which cosmic question you want to explore next.